So we want to find the slope of the tangent line to the curve r equal 1 over theta when theta equals pi. It's not necessary to draw a graph, it doesn't say that, but it's always a good idea to do a quick sketch. It gives you a sense of what you're doing, and it also could help you pick up an error. So if we wanted to figure out what this graph would look like, well, we know that r equal theta was a spiral that started at the origin and spiraled out because as theta increased, so did r. Well, this is the reciprocal of theta, so as theta increases, r becomes smaller and smaller. So we might think of this as a spiral going in, except we've got to figure out what's going on near 0 because this is undefined at 0. So if I had a number very near 0, so a very, very small angle, then r is going to be very, very large, and in fact r is going to approach infinity as we approach 0. Now if we approach 0 from the positive, then it's going to get very large out here just a little bit above this x-axis. And what if we approached 0 from a negative angle? If we were looking at that, we would have a very large negative radius, so we would be out this way. So kind of interesting right around 0. We could actually plug in values like pi over 4, pi over 2, 3 pi over 4, and pi to actually get other points that would be finite. And if we did that, putting in pi over 4, by the time we do the reciprocals, 4 over pi, that's about here 1.3. And then we would come in as we computed these various values, and we would see this spiral coming in. But it's an interesting thing as we look at angles close to 0, this is going to go out very large. Now I actually graphed this then, and it's quite interesting to look at this graph because this first one you're seeing here is when we're coming in from infinity essentially, and we don't see the clear out there, but it comes in and then would spiral around this way, and this piece we're seeing as if we had done negative angles, and we get this negative r that's going out. So kind of interesting. But the big thing we're interested in here is the slope of the tangent at pi. So we can see that right here. So we would expect a negative number when we compute that. Let's go ahead now and find it. So we know the slope of the tangent to any curve is the change in y over the change in x, and we're looking for dy dx here, then the derivative y with respect to x, and we know that is the derivative of y with respect to theta over the derivative of x with respect to theta. And that's the best thing to realize that and then find from there than to try and have a formula memorized. So how is y connected to r and theta? We know that y equals r sine theta, but in our case r is 1 over theta, so it's going to be 1 over theta sine theta. So if we did the derivative, we need a product rule. First times the derivative of the second plus the second times the derivative of the first. That's negative 1 over theta squared. Now, if we looked at how x is connected, we know that x equals r cosine theta, and our r is 1 over theta. So 1 over theta cosine theta. So we've got another product rule. First times the derivative of the second plus the second times the derivative of the first. Now there's no need to even try and do any kind of simplification because what we are interested in now is evaluating this when theta equals pi, and we will have the slope of the tangent to the curve at pi. So we have 1 over pi cosine pi minus 1 over pi squared sine pi, and that's divided by negative 1 over pi sine pi minus 1 over pi squared cosine pi. So let's go ahead and do some simplification. We know that sine of pi is 0, so those are gone. Cosine of pi is 1. So what we have left is 1 over pi divided by negative 1 over pi squared, so that's going to simplify to negative pi. And that looks reasonable for the slope of the tangent to the curve then at pi.